Good morning, students. In this session, I am going to discuss the general characteristic of group 2 alkaline earth metal compounds. So, let's first discuss the general characteristic of compounds of alkaline earth metal. At first, we will discuss about the general characteristic of oxides and hydroxides of group 2, means alkaline earth metal group. So let's discuss what are the characteristic of oxides and hydroxides of group 2 elements. Group 2 elements the forms the type MO. They are obtained by heating the metal in dioxygen. Heating the metal in dioxygen or by thermal decomposition of their carbonates. For example, at first, metal of group 2 elements form oxides. For example, magnesium burn with oxygen to form magnesium oxides, and M carbonate means metal carbonate being decomposed to form oxides and carbon dioxide. For example, when calcium carbonate heated form calcium oxide and carbon dioxide. So in this way we can form the oxides and hydroxides of alkaline earth metals. Let's discuss the characteristic of their oxides and hydroxides. What are the characteristics? Except beryllium oxide, all other oxides of group L, all other oxides of group 2 elements form rock salt structure. The enthalpy of formation for these oxides are quite high. And therefore they are stable to heat. Beryllium oxide is amphoteric. Whereas Other oxides of this group are basic in nature. Other oxides are basic nature. They react with water to form springly soluble hydroxide. Hydroxides. To form M hydroxides. For example, calcium oxide and water to form calcium hydroxides. Let's discuss the nature of hydroxides or characteristic of hydroxides.
Mummy.
Hydroxides, they form hydroxides of type MOH2. Hydroxide of calcium, strontium and barium are obtained either by treating metal with water or by reacting with metal oxide with water. So properties of hydroxide is properties. Beryllium hydroxide is amphoteric in nature. Amphoteric means they dissolve both acid and as well as base. So let's see the reaction of beryllium hydroxide with acid. It will form beryllium chloride and water. Let's balance this equation. Beryllium 2HCl or better write 2H2O. So beryllium hydroxide is amphoteric in nature, react with acid as well as base. So when beryllium hydroxide treated with sodium hydroxide, it will form Na2BeOH whole 4 sodium berylate, light LITE, sodium berylate. So this type of reaction is important for beryllium. It is amphoteric in nature, so it shows the reaction with acid as well as base. The hydroxide of magnesium, calcium, strontium and barium are basic in nature. Their basic strength increases, basic nature and basic strength increases when we move top to bottom in the group. So strength increases down the group. So let's discuss the next characteristic of alkaline earth metal of compounds, halides. So halides. All alkaline earth metals form halides of type Mx2 They form action of halogen or halogen acid on the respective metal. So they form by the action of halogen or halogen acid on the respective metal. M form MX2 type. For example, magnesium react with chlorine to form magnesium chloride, or M if treated with halogen acid, formation of halide along with hydrogen gas. For example, calcium hydrogen bromide to form calcium bromide and hydrogen gas. So metal oxide, metal hydroxide, metal carbonate react with halogen acid to produce metal halide also. So metal oxide, metal hydroxide and metal carbonate all reacts with halogen acid to produce metal halide. For example, MO metal oxide plus halogen acid to form MX2 and water. Metal hydroxide also react with halogen acid to form metal halide and water. Metal carbonate react with halogen acid to form metal halide, water and carbon dioxide. So balance this equation. So in this way you can balance all the reactions. So this is the reactions related to the halides. Let's discuss the properties of halides. Properties. Beryllium halides are covalent. Beryllium halides are covalent. They are soluble in organic solvents. They are soluble in organic solvents. Covalent compounds are mostly soluble in organic solvents. Beryllium halides are covalent. According to Pajan's rule, we have discussed number of times in the previous video how the compound's nature becomes covalent. In fact, the first member of each group has the anomalous or shows the anomalous characteristic. So, and are hygroscopic organic solvents and are hygroscopic. Hygroscopic nature. Their aqueous solution is acidic due to hydrolysis. So, if beryllium chloride in aqueous medium, it shows beryllium hydroxide and hydrochloric acid. So their aqueous solution is acidic due to hydrolysis. Their aqueous solution is acidic due to hydrolysis. The halides of other alkaline metal, the halides of other alkaline earth metals are ionic in nature. The ionic character increases on moving down the group. Ionic character increases on moving down the group. Means beryllium chloride, then magnesium chloride, then calcium chloride, strontium chloride, and barium chloride. So ionic character increases when we move top to bottom. Structure of beryllium chloride. In solid state, beryllium chloride has polymeric chain structure. Like this: beryllium, chlorine, beryllium, chlorine, beryllium. So the lone pair or coordinate bond formed between this chlorine and this beryllium, also coordinate bond formed by chlorine here, and likewise this beryllium and this form like this. So in this way, beryllium, the outermost electron is 4 and it formed 2 covalent compound with this chlorine. So they have become 6 valence electron and 2 electrons, means 1 lone pair denoted by 1 chlorine atom. So in this way it completed their octet. So in the solid state, beryllium chloride has a polymeric chain structure. So draw this structure and learn it. This is the polymer form of the beryllium chloride. Now the dimer. So let's discuss the dimers when 2 monomers combine to form dimers. So at first we draw the dimer, beryllium chloride and beryllium chloride. This is the monomer, and when 2 monomer combined forms dimer. So beryllium chloride and this chloride and beryllium chloride. So this coordinate bond formed between this chlorine and this beryllium. Likewise here the coordinate bond formed between this chlorine and this beryllium. So one monomer is here and one monomer is here. So beryllium chloride 1 monomer, beryllium chloride 1 monomer. So this type of dimer structure formed by the beryllium chloride. So BeCl2, VCl2. So one chlorine atom donate the electron pair to this beryllium ion, and this chlorine attached with beryllium. So this donate the electron pair to this beryllium ion. So in this way, in the solid form, structure of beryllium chloride and vapor state also. So beryllium atom present in sp3 hybridized state, and see what is the structure of beryllium chloride in solid state and vapor state. So solid state and vapor state. So it is important for the examination point of view. Let's discuss the next property, next compounds and their property. Number third, salts of oxoacids. Salts of oxoacids. So in this way, salts of oxoacid, in which we will study about the carbonates and bicarbonates. Carbonates. Salts of oxoacid is H2CO3, H2SO4, H3PO4, phosphoric acid, nitric acid, HNO3. All these are known as a oxoacid. So oxo salts contain one or more oxygen atom, that is carbonate, bicarbonate, sulfates, nitrate. This is the carbonates ions of oxoacids, sulfates ions of oxoacids. So in this way we can define the what do you mean by the oxoacid. The oxo salts contain one or more oxygen atom, that is carbonates, bicarbonates, sulfate, nitrate, etc. So in which we will study about the carbonates and bicarbonates. Alkaline earth metals form carbonates and bicarbonates, and their formula is MCO3 and MHCO3. Carbonates and bicarbonates. So carbonates are colorless. They are the colorless, crystalline solid, insoluble in water, They can precipitate by adding sodium carbonate or ammonium carbonate solution, to a soluble salts of this metal. These metals, for example, calcium chloride, Na2CO3 means sodium carbonate. So we can get calcium carbonate and sodium chloride. Similarly, barium chloride with ammonium carbonate. This compound helps to precipitate. So formation of barium carbonate and ammonium chloride. Balance this equation, ammonium chloride. So 2NaCl. So let's we discuss the properties of carbonates and bicarbonates. Properties of carbonates. All carbonates decompose on heating. All carbonates decompose on heating. The thermal stability of carbonate increases with increase in the atomic size. Beryllium carbonate is unstable and can be kept only in an atmosphere of carbon dioxide. So beryllium carbonate is unstable, so that it can kept in a atmosphere of CO2. So beryllium carbonate and magnesium carbonate, calcium carbonate, strontium carbonate and barium carbonate. So their thermal stability increases with increase in the atomic size. So let's we discuss about the bicarbonates, the property of bicarbonates. Bicarbonates are soluble in water and decompose on heating to give carbonates. For example, calcium bicarbonates when heated form carbonate, carbon dioxide and water. The next is the sulfate. The next compound is the sulfates of alkaline earth metal. So sulfates are mostly white solids, Beryllium sulfate and magnesium sulfate are readily soluble in water. The solubility decreases from calcium sulfate to barium sulfate. What are the reason? A compound is soluble in water if first its enthalpy of hydration is large and lattice enthalpy is small. Means hydration enthalpy must be greater than lattice enthalpy. So this is the condition for solubility of the particular compound. The hydration enthalpy of magnesium and beryllium. Magnesium and beryllium ions are large due to their small size. So as we move top to bottom, the size of the cation increases. So the hydration enthalpy and their solubility in water decreases. The lattice enthalpy remain almost same on going down the group. So write down the reason also. The hydration enthalpy of beryllium and magnesium ions are large. Ions are large due to their small size. As the size of the cation increases on going down the group, their hydration enthalpies and their solubility solubility in water decreases. The lattice enthalpy remain almost same on going down the group. Due to small enthalpy of hydration, strontium sulfate and barium sulfate are almost insoluble in water, magnesium sulfate. When heated, it will form magnesium oxide and sulfur trioxide. So the electropositive character increases positive character increases on going down the group. The stability and decomposition temperature of the sulfate also increases. Beryllium sulfate is highly stable. Next we discuss about the nitrate of the group 2 elements. They form nitrates of the type MnO3 whole 2. Metal nitrate are prepared by the action of nitric acid on metal oxide. Metal hydroxide, metal carbonate. Metal oxide, nitric acid form metal nitrate and water. Metal hydroxide, nitric acid form metal nitrate and water. Metal carbonate, nitric acid form metal nitrate, carbon dioxide plus water. Metal nitrate, when decomposed to form metal oxide, nitrogen dioxide and oxygen gas, they decompose to form metal oxide, nitrogen dioxide and oxygen. Metal oxide, nitrogen dioxide and oxygen. So in this way we have completed our important compounds and characteristic of group 2 elements. So in the next video we'll discuss about the next topic, that is the p block elements. So students, do all the questions answer of this particular S block elements related to the group 1 and group 2 of the NCERT question, in-text question or exercise questions. In the next video we'll discuss the P block elements, in which we'll study about the group 13 and group 14.